Usually when we interact with the technology around us, there's just this underlying expectation of magic.
Oh,
L-
absolutely, yeah.
Like you tap a piece of glass and a par shows up. You speak into a little cylinder on your kitchen counter, and suddenly your favorite playlist kicks in. We're entirely conditioned to just demand the result.
Right, while being completely shielded from the actual mechanism that makes it happen.
Exactly.
It's a culture of frictionlessness. I mean, the less we have to think about how a system works, the more successful we deem that system to be.
But then, you encounter a mind that absolutely refuses to live that way.
Yeah.
Someone who insists on prying the back off the clock, pulling out all the little springs and cogs, and then reassembling them by hand.
Just to prove they actually understand how time is being kept.
Right. And today's source is just a masterclass in pulling the back off the clock. We are doing a deep dive into a highly technical blog post from qianmeng.org. Specifically, it's a post titled Notes on Haskell Programming, Part 86.
And the author, Qianmeng Yang, refers to himself simply as an old software plumber.
Which I love.
Right. It's a very humble title for someone who is engaged in one of the most rigorous public learning exercises you will ever see on the internet.
Seriously. If you look at the archives of this blog, it stretches all the way back to 2011. And it's not just, part 86 on Haskell. You'll find part 841 on gardening.
Wow.
Yeah, part 212 on fish keeping. He meticulously logs his guitar practice, his diet, and incredibly detailed betta fish spawn logs month after month, year after year, all the way to March 2026.
Yeah, and when you zoom out and look at that 15-year archive, you realize this isn't just a digital diary.
Right.
This is a deliberate, highly structured architecture for understanding the world. He's basically building a framework for how to learn. And to truly grasp that macro philosophy, we're going to zoom all the way in on one specific micro decision he makes in his Haskell code.
Let's get right into that decision because it completely flies in the face of how most developers operate today.
It really does.
Ang is writing a Haskell program, and he deliberately chooses to reject a very popular piece of programming magic called the OverloadedStrings extension. He explicitly states he's skipping it to maintain a, quote, pure Haskell approach.
Right, and to understand the weight of that choice, you really have to look at how Haskell handles text natively.
Okay.
By default, if you type a word inside quotation marks in Haskell, the compiler treats it as a string type. But under the hood, a standard string in Haskell is actually a linked list of individual characters.
Oh, wow. So for heavy text processing, that is incredibly inefficient.
Exactly. Every single character is a separate node in memory.
Right. So if you're building anything modern, you generally avoid the default string and use a much more robust data type called text.
Which is exactly what Ang is doing. He has some variables, he names them int,
Yeah.
that hold captured data, and he has strictly defined them as this efficient text type.
But, and here's where the friction starts, he also needs to match a literal Chinese character, specifically the character for date.
Right. And because he's typing that character directly into his code, wrapped in quotes, Haskell's default behavior just kicks in.
It just assumes it's a string.
Exactly. The compiler sees it and says, oh, that's a traditional string. He also notes, by the way, that he's using a char approach instead of string to match single Unicode characters, which fits his specific matching rules.
But the core problem remains, right? He has a fundamental type mismatch.
He does.
He's got variables in the robust text format, but his literal Chinese character is sitting there in the standard string format. And in a strictly typed language like Haskell, you can't just mash those two together.
No, the compiler will absolutely scream at you.
Right. You have to convert them. You have to explicitly take the string and pack it into text.
And the friction doesn't even stop there.
Of course not.
When his program finishes his logic and he finally wants to display the result on the screen, he calls a standard core function called prelude.put_strln.
Which is the print function.
Exactly. But that print function is old school. It doesn't understand the modern text type. It only understands string.
Oh, man. So Ang has to take his final text output and explicitly unpack it back into a string just so the screen can render it.
Yep. He has to pack the data to do the work and then unpack the data to show the work.
Okay, wait. I write code and I use auto-formatters and syntactic sugar all the time to avoid exactly this kind of boilerplate.
Sure, most people do.
This is exactly what that overloaded strings extension was built to solve. If he just turns that extension on, Haskell magically understands that his quoted literal text should be treated as the robust text type right from the start.
Right. It wipes out all that explicit packing clutter.
So by rejecting it, isn't he just intentionally driving a manual transmission in stop-and-go traffic? Why make the code harder to write?
Well, it looks like unnecessary friction on the surface. But Ng's rationale points to a massive abstraction leak in modern programming.
Okay, how so?
He notes that even if you use the overloaded strings extension to hide the initial packing, he would still have to manually unpack the text at the very end to print it.
Oh, because the print function still only takes strings.
Exactly. The extension only handles half the pipeline.
Yeah.
Unless he went through all the trouble of swapping out the core print function entirely, the mismatch still exists.
Ah, I see. So the magic extension doesn't actually solve the architectural mismatch. It just sweeps half of it under the rug so you don't have to look at it.
Precisely.
Huh.
And for Ng, sweeping complexity under the rug is basically the antithesis of learning.
Right.
He sticks with the pure and explicit approach because he doesn't want the compiler doing silent favors behind his back. When a machine handles the data conversion silently, the developer's mental model drifts away from what the hardware is actually doing.
He wants to see the gears turning.
Yes, Ng wants the code on his screen to be a literal, unapologetic map of the data's journey.
That makes a lot of sense. And this obsession with making the pure logic visible, it doesn't stop at data types.
Not at all.
It's the core driver of how he handles actions in his code. Ng writes about needing to iterate over a collection of book titles to print them out to the console.
Right.
Now, if you come from a language like Python or JavaScript or even Elixir, which Ng also writes about extensively, you just write a simple for loop or use something like enum.each.
But Haskell forces a completely different paradigm.
Yeah, Ng points out that the Haskell equivalent for his specific need here is a function called mapm_.
And mapm_ requires us to talk about monads.
Oh boy, the dreaded monad.
I know, but Ng keeps his explanation wonderfully grounded here. He explains that compared to a standard map function, which just transforms a piece of data into a new piece of data, the M in mapm_ stands for monadic.
Meaning what, exactly?
It signals that this operation is happening within a specific context.
Yeah.
And that context is the absolute frontier of pure functional programming, the I/O context.
Input and output.
Right. You have to remember, Haskell is built on pure mathematics. In pure math, a function is a static truth. If you put a 5 into an equation, you get a 10 out.
Always.
Always. Doesn't matter if you do it today, tomorrow, or 1,000 years from now. The answer is 10. Pure functions have no concept of time, and they have no concept of state.
But printing a line of text to a computer monitor requires both time and state.
Exactly.
When you are permanently altering the pixels on a physical screen in the real world, that is a massive side effect.
It is a total contamination of the pure math. So Haskell quarantines that side effect.
Okay.
The I/O monad acts essentially like a biohazard suit. It allows your pure, stateless code to reach out and touch the messy, stateful, real world like a monitor or a database without contaminating the rest of the program's pure logic.
That is a great analogy.
Yeah, so when Ng uses mapm_, that M is him explicitly putting on the biohazard suit.
And then there's the underscore at the very end of mapm_. Ng notes that the underscore is an explicit instruction to just discard the return value.
Which is a brilliant requirement. Think about what a standard map function does.
Okay.
If you map over a list of numbers to double them, the entire point of that operation is the new doubled list you get back. You care deeply about the return value.
Right. So if a regular map function is like translating a document, where the whole goal is to get that new translated paper handed back to you, then mapm_ is basically just standing up and reading the document out loud to a crowded room.
Yes, that's exactly it.
Yeah.
And to push that analogy further, if you translated a document, you could shove it in a desk drawer and read it next year. The data is static.
Right.
But an action, like reading out loud, happens in time. It permanently alters the state of the room. The people in the room heard it. You can't undo it.
And when you finish reading out loud, you don't need someone to hand you a physical receipt proving that you just spoke. The action itself was the entire point.
Precisely. The mapm_ function is explicitly for when the real-world side effect is the only goal. Haskell forces you to use this specific monadic version with the underscore, so you cannot accidentally trigger an action.
You have to be so intentional.
You do. You have to announce to the compiler and to yourself, I am stepping out of the realm of pure math. I am altering the real world, and I am doing it solely for the action.
It's the exact same philosophy as rejecting the overloaded strings magic.
Yep. He demands absolute, explicit control over when his code touches reality.
But, his commitment to this absolute explicitness immediately creates a structural roadblock.
It does.
He has his list of chapter titles. He wants to iterate over them and trigger his side effect, printing them to the console. But remember, his titles are in that robust text format, and his puts_drln print function only accepts standard strings.
Right, so he has to unpack them before he prints them.
Exactly. But he points out that the unpack function only works on a single item. Because his titles variable is an entire list of items, he can't just pass the list to the unpack function. The compiler throws a type mismatch error.
It's the classic functional programming dilemma. You have data in shape A, you need it in shape B to execute action C.
Right.
But your conversion tool only works on one piece of data at a time, not the whole collection.
Now, if you're writing this in JavaScript or C++ test array, an old software plumber would just write a loop.
Sure.
He'd initialize an index variable, say I = 0, and tell the computer to step through the array, unpack the item at index I, print it, increment I by 1, and just repeat until the array is empty.
But that standard for loop requires mutable state. You have to constantly change the value of I.
Right.
It requires moving parts. It's like building a bucket brigade to put out a fire.
Yeah.
You have a variable handing data to the next step over and over. And bucket brigades are prone to error.
Oh, absolutely.
Someone trips, a bucket spills, you get an off by 1 error, and your whole program crashes.
So Ang completely bypasses the bucket brigade. He avoids writing a messy custom loop entirely by using the function composition operator.
Yes.
And in Haskell, this is represented simply by a dot, just a period.
Which is arguably one of the most powerful concepts in pure functional programming. Instead of building a mechanism to move the data, he alters the functions themselves.
Ang maps the math out perfectly here. He has his unpack function, which transforms text into string. And he has his print function, puts_drln, which takes a string and performs the I/O action.
Right. So rather than manually passing data from the first function to the second function inside a loop, he uses the dot operator to fuse the two functions together into a single brand new function.
It's like instead of a bucket brigade, he's basically threading a pipe.
I like that.
I mean, he is an old software plumber, after all. He takes the output valve of the unpack function and he welds it directly to the input valve of the puts_drln function. The dot is the weld.
That is exactly what is happening mechanically. He fuses them together into puts_drln dot unpack.
Wow.
There are no index variables to track. There is no I = 0. There's no state to mutate. He has created a single, seamless pipeline.
And then he just hands that customized pipeline directly to map m_, which efficiently pushes every item in the list through the byte.
The data just flows right through.
It's incredibly elegant because it eliminates the possibility of human error in the loop's logic.
Right.
He isn't managing the iteration at all. He is just defining the plumbing and letting the data flow.
This is pure logic made visible. He is snapping together highly tested, isolated behaviors without relying on hidden state or background magic.
And this methodology, this absolute refusal to hide the mechanics of his work, is exactly what causes Ang to pause halfway through his highly technical post.
Yeah, he takes a step back.
He steps back from the Haskell compiler, the monads, and the composition pipes, and he explicitly addresses why he is writing this post in the first place.
He actually writes that he's having a blast putting the post together.
Right. He is genuinely enjoying the friction. He connects his coding style directly to his learning style. He states that writing this blog post is him actively applying the Feynman Technique,
which is named after the physicist Richard Feynman.
Right.
The core premise of the Feynman Technique is that true comprehension is basically impossible until you can explain a complex concept in simple foundational terms to someone else.
Or, as Ang is doing here, explaining it to himself.
Exactly.
And then Ang drops what is arguably the most vital insight in the entire source material.
Yeah, this is the big one.
He writes that applying the Feynman technique is the only way to prevent the illusion of competence. And he specifically calls out how dangerous this illusion has become today under the usage of AI.
The illusion of competence is the psychological trap of our modern internet.
Definitely.
We have engineered all the friction out of acquiring information. You can ask an AI to summarize a highly complex Haskell architecture, and within 2 seconds, it spits out a flawless, perfectly formatted explanation.
Yep.
And because that output is so clean and easy to read, your brain experiences a dopamine hit. It tricks you into believing that you possess that knowledge.
You confuse the ease of consumption with the depth of comprehension. It's exactly like watching a highly polished, heavily edited DIY video on how to frame a house.
Oh, that's a perfect example.
Right. The AI narrator has a perfect voice, the camera angles show the wood snapping together effortlessly, and it makes complete sense in your head.
Oh.
But the second you step onto a muddy construction site and actually pick up a physical hammer, you realize you don't even know how to properly grip a nail.
Right. The video gave you the vocabulary, but it didn't give you the neural pathways.
Mm.
The AI gave you the illusion of competence.
And Eng is doing the mental equivalent of swinging that hammer every single day.
Yes.
He explicitly notes that merely reading Haskell code is superficial. It just isn't enough. By forcing himself to write this blog post, he's forcing his brain to reorganize its thoughts. He's intentionally exposing his own knowledge gaps.
And this brings the entire 15-year archive of his blog into focus.
It really does.
Those thousands of posts, from Haskell types to gardening to betta fish spawn logs, they aren't just a hobby. They're his active daily defense mechanism against a frictionless world.
Wow. He refuses to use the OverloadedStrings extension in his code for the exact same reason he refuses to just passively read about programming.
He understands that true mastery requires you to feel the gears turning. You cannot outsource your understanding to a compiler extension, and you cannot outsource your thinking to an AI summary.
You have to manually pack the data.
You have to manually unpack it. You have to explicitly weld your own understanding together, concept by concept, until the structure is undeniably yours.
Man, what a journey. We started today in the weeds of Haskell string formatting.
We really did.
We looked at the critical difference between a default string and a robust text type. We explored why Haskell uses the IO monad as a biohazard suit to manage stateful actions in a stateless environment.
Right.
We saw the mechanical elegance of welding functions together with a single dot rather than relying on mutable bucket brigades. And we arrived at a really profound philosophy for how to survive an era of effortless information.
We arrived at the hard truth that sustainable deep learning requires friction.
It really does.
So, if relying on hidden magic in AI summaries creates an illusion of competence, if it tricks us into thinking we know how to build the house just because we watched the polished video, then we really have to look at our own habits.
Oh, absolutely.
What is one area in your life right now where you have been cruising on automatic? What would happen if, today, you force yourself to turn off the autopilot, use the Feynman Technique, and explicitly write out the underlying mechanics of what you think you already know?
Find your clock, take the back off, and start examining the gears. Thank you so much for joining us on this deep dive.